So welcome to the contributor Q&A panel for part of KVM Forum and OSS Shier track. So some of you may be already familiar with this format, but for those who are not, so this is the structure of the panel. It's like this. We have a live Etherpad there, etherpad.net/p/KVM Forum 2000 panel / I mean, when I say slash. So I hope you can see that. So go up there and type the questions, and we'll take it from there. Do the panelists want to start? Okay, I'm Kashyap Chamarthy, and I work for Red Hat's cloud engineering group, integrating KVM-based components into OpenStack. So I interact with a lot of KVM, QEMU, libvirt components. Andrea?
Hi everyone, I'm Andrea Arcangeli. I work on the Linux kernel and KVM. I've been involved since more than 20 years ago, and mostly on the memory management. So memory management and virtualization memory management.
Hey, I'm Konrad Wilk. I manage the Linux security, virtualization, and containers group within Oracle. Do both upstream work and then inside. And also working on the Zen project. I don't think I've worked so long as you, but I can't remember how long, so it must be long.
Yeah, hi, I'm Noel. I'm Director of Engineering for Virtualization and Networking at Red Hat. And I'm an old kernel engineer, but not Linux. I switched over to management to come work at Red Hat in 2011. But I've actually been doing kernel, memory management, hypervisors. I did the live migration project for our hypervisor at HP and ported to multiple architectures.
I'm Dave Woodhouse, Principal Engineer in Amazon's kernel and operating systems team, looking after the hypervisors for Zen and KVM running EC2.
I'm Peter Shier. I'm from Google. I work on the Google Cloud kernel team. My focus is on nested virtualization. I've only been there about 2.5 years. Prior to that, many years at Microsoft in drivers and firmware.
Okay, so we may not go sequentially to the Etherpad, but to start off probably gentle. So one of the questions is the backup questions take up on small footprint VMs. So there's been a pressure of containers that has triggered a set of projects of new virtual machine managers. Any thoughts on this space and how that comes into picture with KVM?
I'll start.
Go for it.
It's a fantastic opportunity to actually remove some of the depths that we have, technical debts, because all the stuff that's one of the neat features of containers is you need to narrow things down, make it faster. So by that virtue, we can expand it and actually trying to make things faster, which is always great.
Yeah, so we've been driven by this quite a lot, reducing the footprint and getting stuff to spin up really fast and do something and then spin down, and people want to do that in a VM. And this is why we have the Firecracker project, which, yes, we've got to throw away a lot of the technical debt. We've got something clean and fast, and it's not just technical debt in the implementation, it's what we're offering to the guests. You know, we don't have to offer all the legacy hardware. It allows us to do a lot of interesting things.
So in the kernel specifically, there are also page hinting and VirtualOpMem, which has been merged recently. They both tend to make the guests from a memory, especially memory management point of view, have a footprint very similar to the host. So I've been attending many Kubernetes meetup, and I don't think all the containers engineers and all the people working with containers are aware that virtual machines are getting slimmer. And this technology, for example, allows to avoid having to assign too much memory to a guest, and you can use the same memory pretty much that you would have on the bare metal.
So I'd just like to mention that from my perspective, the engineers at Red Hat are working to make QEMU have a smaller memory footprint. and you should go to Paolo's talk on Friday. We're also working on integrating Kata into Fedora.
Okay, so next up, it's about fuzzing. So this KVM syscaller is one of the Linux fuzzing, coverage-based fuzzing tools, and it's finding security problems in KVM. So there's not a systematic structure or systematic effort in KVM to have fuzzing. So any thoughts on fuzzing in KVM? Go for it, Peter.
So one of the things that we've seen with syscaller is fuzzing the KVM interface, which is great. But I think one of the things I would love to see, and I suppose I should speak to my own colleague who's behind syscaller, is fuzzing from the guest level in a much more organized way, looking at various guest interfaces and trying to break through from the guest.
I wanted to add something that there is already work in trying to do some of this for Vert.io and fuzzing on that side. But also interesting, I think the question was geared like, are we using? Yes, I mean, so Oracle Linux does use fuzzer and uses syscaller to try to actually make it better and faster. Less problematic. Now, if you actually had a chance to look at the Linux Security Symposium, and I think Dimitri was presenting, LPC, you will see that a large percentage of people are working on doing fuzzing on the upstream because it's in your mind, right? But stable trees are much more difficult because it's harder. So I'm really much looking forward to seeing a better evolution of stable trees, also having a lot of this done, which will make all the enterprise kernels and all the enterprise products be more safer and secure.
Yeah, I was going to say syscaller is great. It finds a lot of great bugs, and running it upstream on x86, I was just curious because I've heard that it's pretty much finds all the bugs on x86, and it doesn't really need to be run on other architectures. So I'm curious if people have opinions on that.
There's been, speaking of other architectures, and last year there was a talk by Christian Waterger on collaborative efforts between multi-arch. So probably we can take a segue into supporting multiple architectures with KVM. I don't think you can see me, but I want to take that question about multi-arch support with KVM. Supporting multiple other architectures.
Yes, it does.
It does, but the last year the talk was about better collaboration.
Yeah, I liked Christian's message from last year about the different architectures collaborating. That was a really good talk. So from my perspective, what different perspective can I give? And that is the business perspective, maybe? Like we need demand for these other architectures, or the distributions don't need to support them?
We're working on demand for non-x6. And yeah, as we do that, there's a lot of stuff that can be more generic. And historically in Linux, not just KVM, across the board in Linux, we've re-implemented a whole bunch of stuff per architecture, entirely gratuitously. And yeah, and even earlier today, Christian was talking about timers and counters, which are just gratuitously different. And we do it all over the place, and we shouldn't. We still haven't quite learned, but we're getting there slowly.
Okay, so switching gears, there's something about virtual machine introspection in KVM. So since apparently 2017, there's this Bitdefender pushed a patch to make KVM a first-class citizen for VM introspection. Does anybody have any thoughts on that? Is KVM upstream community interested in it, or any other related thoughts?
So they have a neat product which allows you to do kind of kernel integrity. You can figure out things, those of you guys who don't know, if if the guest is working correctly. And it's awesome for finding viruses because you can figure out things are out of pattern. And they have all the patches for KVM and also for libVMI, which is a nice interface that does it. That's great for academic research as well. The problem with always patches is that they keep on growing, and they get longer and longer, and that's always a problem, but it would be fantastic to have it. Though, the Intel and AMD both have memory encryption mechanism, which really throws a wrench at this whole family. So I don't really know what the good answer is, and I don't think that has been yet answered, and that should be as part of what the future of it is.
It's a tricky concept for us, just operationally speaking. I mean, one of the fundamental things about running a cloud provider is that the whole business is based on trust. And one of the ways we preserve that trust is by having a clear line between customer data and our stuff on the hypervisor side. And if we're ever going to have extra code on the VMM side, on the hypervisor side that touches customer data, we need to have a good reason for that. And so there is a natural resistance to anything like this where we're just, looking at customer data to see what's going on today. That crosses that bright line that is our starting point for how we design things. So it's not obvious how we would do this in practice.
Just have to plus one that as a cloud provider. That was going to be my comment.
Yeah, the same thing here. We struggle the same thing. How do you actually make it so that it doesn't compromise the privacy and security and the customers have?
Okay, I'm picking something randomly. This is going to be an interesting can of worms, I think. This year we had the MDS, the microarchitectural data sampling attacks, and thoughts on performance implications of that, especially in context of simultaneous SMT and hyperthreading, what Intel calls it as hyperthreading.
So folks have probably read Slashdot. Greg Cage gave a great example of performance versus security, and they're kind of both contradicting each other. It's an ongoing struggle we all have, which is the cloud providers. One of the tenets is the privacy and security of customers is the most important thing. So, but at the same point, customers are not really thrilled if they run at a speed of 46, so performance is also important. There's multiple ways of attacking this or trying to solve it, and there's a whole bunch of work. And we're looking forward to one of them being address space isolation, which tries to basically carve out pieces of the KVM that would be okay to run without any, you don't actually have to do much of. You consider it more as a clear text, as in if the data gets leaked from the kernel, that data is okay to be leaked. But otherwise, you have to add in like a more firewall. And we're looking forward to that being as a solution to security and performance at the same time.
So at Red Hat, we ship the enterprise kernel with the same defaults for the mitigation setting as the upstream kernel. So we don't deviate, but we go really the extra mile to provide you not just low risk. For example, there is this risk of an attack based on a deep cold stack is considered low by some specification. Well, we also provide a way not just for you to have low risk. We warn you at every boot that in some chip you might have to opt in on some IBRS option to get zero risk. The same is true for no SMT. We warn in other places when you install, and basically we go the extra mile to be sure you can reduce the risk to zero. We understand that for most people, the first line of defense, and for most technology, not just the users, but also from products like, I don't know, Firefox or containers or anything, which is using seccomp, and we enable SE Linux by default, so you have the first line of defense, enable it, that's probably the most important thing, but we go the extra mile also on the last line of defense, where if you get attacked and you have a problem, you can also have full security and zero risk from these speculative attacks against the, let's say, CPU features.
So in one sense, we got lucky because the design of our hosts, a lot of them do static pinning. We're not allowing vCPUs to roam, and static setup of memory, and even PCI pass-throughs, so we're not constantly taking VM exits for I/O. Theoretically, on modern hardware, we ought to be able to get to a point where we're counting in tens of VM exits per minute. I mean, we're not actually there yet, but you could hypothesize about getting there. And the cost of these mitigations is on the entry and exit. And so we can actually be fully secure theoretically with very little overhead. It gets harder once you're doing actual VirtIO.
I forgot to say one thing, which is, I'm not sure if I'm allowed, but I'm going to have a presentation on Friday. Is it fair? Where I'm going to show the effect of all of the mitigations on KVM, specifically on the VM exit of KVM. So if you are interested on the topic, I think Friday might be interesting for you to attend.
So we're obviously investing heavily in every attack that comes our way. I think the thing that's hit me personally more than anything is that this is the new in vogue attack, and there will only be more, and they will be coming for a long time. I saw a wonderful presentation from a researcher at University of Michigan in which he asked, how many side buffers do you think there are in Intel processors? And people put up their hands, 5, 10, 15. And the answer is nobody knows. So I don't know if that's true, but it's more than we know to deal with today. So I think we see this as something that we're going to invest in. We actually plan our schedules assuming that there'll be a couple of these a year and that we need to have people set aside to deal with them.
Although there has been a trend recently that they discover a new one and the mitigation is still co-scheduling and flashing caches, and oh look, we already did that. So from a software mitigation point of view, okay, nothing to do for this week's vulnerability, but in terms of them eventually maybe one day fixing the hardware, then they're really playing whack-a-mole. I don't know how the hardware is going to be fixed.
Yeah, but that'll be interesting. Yeah, I'm looking forward to that. Past couple of years have been really interesting. I'm very fortunate to have 2 people on the team that have been involved in the developing the mitigations upstream, so it's been really interesting watching it. And also sort of a new field and a new reason to run KVM, new reason to run encrypted VMs. So it's great to see all this development happening.
I wouldn't say interesting, more like stressful.
Sometimes stress is fun. I mean, we all love our jobs, right?
May live in interesting times.
Yes.
Speaking of that same topic, the other day I noticed on LWN.net that the kernel has a new process altogether for embargoed issues, hardware embargoed issues. I know it was recently merged, but any thoughts on how that's working out or not?
So I'm one of the ambassadors on that list, and sorry, I can't say anything.
So on LWN, we can say what you can read on LWN, right?
It's in the Git, it's in the Linux tree. It's committed in the Linux tree.
That too, right? Of course. So the current status is we have a very good collaboration right now. It wasn't the case immediately because immediately it's the thing, we didn't have a process to handle anything like that. So we were not prepared, and this is not only a Linux issue, every OS actually is involved, including the ones you shouldn't be using, by the way. So basically, we had this process started. Now it's really much better. So we have encrypted mailing list, and now there is even a process for any new issue. So if you check Greg 3, there's this mailing list hardware, something at kernel.org. Well, I'm sure if you have one of these issues to report, you will find the right mailing list. I don't remember the exact address. I asked it just a few seconds ago to Thomas, but this mailing list is the one you should send the message, and they will take care of creating a proper channel where they will bring the experts. and this is going to be fluid from now on. And so even the latest issues, maybe you notice that there's not so much press coverage anymore on things like MDS. One of the reasons also people is a little more relaxed is because now we have a process, it's not something you are unprepared. So these things really should be for you, for users of the kernel, just normal updates, because if I'm just making an example, for example, dirty code is much worse than any of these issues. So it's not like you shouldn't have updated the kernel or worried before. You need to have a trusted provider, trusted software distribution where you get the updates from to protect from these issues and anything like dirty code that happened before and that might happen in the future.
So when Spectrum Meltdown happened, the handling of that was, well, with my corporate branding on, I'll probably just say moderately suboptimal. If you want the full stream of invective that describes it more accurately, ask Thomas. And we've refined the process and we worked out how things should happen. And essentially what we've documented now is just how we're doing it now. It's not, what is documented there is not something new. This is how it has evolved. And it's working tolerably well, given how broken everything is.
Okay, one more along. Sorry, go on.
Yeah, I actually just want to
go on.
Hit the back button just for 1 second. The other thing I wanted to mention on the microarchitectural attacks is my other gut feel is they're going to move lower, and they're going to start looking at the IOMMU and common IPs and system architectures. All right. Once we make the processors fairly difficult to attack, it'll just move to the next layer, and I think that's something we should just be proactively looking at.
Thank you. Something along those lines, how should the KVM community be involved in pushing Linux to Linux virtualization-based security features? So I think they're referring to similar to Hyper-V, VSM, and VBS. I don't know what they expand to, but.
Thank you. So the person we just mentioned, that Liran, he was one of the architects that worked with Alex, who's doing ASI, address-based isolation. So Oracle is taking this very aggressive. We're looking at all the different hypervisor technology, all the academia materials, and trying to make sure that KVM will become the best that it can be, and making sure it's secure for every workload you can have. So this is
I'm referring to the fact that I think there is an ongoing effort in general in the operation system field that we want to modify the operation system to always run under a virtualized environment, a small TCP, like a type 1 hypervisor. And in Microsoft World, what they did is created a secure world that can ensure things like code integrity and run enclaves there and things like that. It's very elaborate. And I'm pretty sure that Linux should be pushed into that direction in order to have generic exploitation mechanism. But this would not happen without the generic hypervisor that Linux runs in to support such kind of interfaces, similar to Hyper-V VSM.
For folks, there's other things to also look at is that containers provide an interesting point of this where the attack surface gets smaller with containers, and that's also a frontier where the existing emulations could also become less important, where the focus is going to be on containers, which does lower the attack surface, which is another area that's, we all want to lower the attack surface by having less code, and by making that possible, or not even less code, but less code being executed, and that is a paramount idea in any security idea.
Actually, bringing up containers and going back to fuzzing, I'm big on the back button. That would be another place I'd love to see fuzzing trying to break out of containers.
Okay, so one more, switching gears slightly, from Peter Feiner, I guess. 32-bit x86 hypervisor is buggy. Should we explicitly drop support for it? I think it's...
Wait, hold on. I'm going to follow you and say, back button and follow you and say,
okay.
I mentioned ASI. There's going to be a talk about it. I really recommend folks listen to it.
Go for it. Okay. Should I repeat that one? 32-bit x86 hypervisor is apparently buggy, and should that be dropped, support for it? Should support for it be dropped? 32-bit. I think it's a...
I'm taking some risk answering this question, I think, because I'm not sure. But I think it might refer not to KVM.
Okay.
It might refer to something which is running power virtualized. KVM 32-bit is bugging?
Your host, you're on a 32-bit
host,
Linux
yeah.
KVM host.
I think nobody questions the value of having a 64-bit host being able to run 32-bit guests. There's obviously value in that. But are there still 32-bit hosts?
That's exactly what I was going to say. And there's still 32-bit hosts. At Red Hat, we don't support any 32-bit. So I can't say from Red Hat perspective. However, I think it's important to have a good deprecation policy because, like we were talking about technical debt, it is important to keep a project healthy, keep the community healthy, get rid of some of the old code, make sure that the time to implement new features is not hindered by old things that need to be supported.
Okay, so there's switching slightly gears different. It's a question of how should, what is the advice for someone starting out with KVM, just starting to try, and what's the good place for someone to start with? Any advice for a new person starting out?
Fix 32-bit?
I was going to say get a mentor, contribute, ask questions.
I think that all depends on the variety of the person, right? If you're really wanting to go into low level, just start looking at KVM tool and how it creates a guest and just Google it, and you'll find some pretty awesome examples of with a couple IACOs, you can create your own little, basically QEMU that can launch a guest that runs nothing, like it, print something to a serial port. But that will give you the great idea of how virtualization works and going through all different stacks, and that's the first step in your journey.
So I would have to agree with the Google it. I think that was a good idea. I would say as someone who learned KVM in the last couple of years, I had to start out, meaning I came from a very experienced point of view, and I said, okay, where are the books? Where are the docs? And the answer is, there aren't any. The KVM documentation that's in the code is a good little starting point. There is one KVM book that will show you how to run stuff with QEMU, and that was good to just get things going. My first assignment actually was VFIO, and what I did, because this is the way I learn, is I just started reading the code and documenting it. So I have a very long document that explains exactly how VFIO works in every way, and I think that's one of the ways you can dig in is just really read. I'm doing that currently on the KVM MMU, which is probably the most complex piece, or at least the x86 part. So if you are up for reading code, get in there and read.
Can you share your VFIO document?
It's highly confidential. It documents what happens in open source.
My suggestion is to get up to speed with things like GDB stub, which are awesome in QEMU, and also BPF tracing. And these things, can help familiarize. I remember when I started with the kernel, the very first bug I fixed, I put print K in every function. You don't have to do that anymore, right? So these things are so much better nowadays, and it's really good to familiarize with all the debugging goodies we have. So there's even a new project I used recently to find a horrible memory leak caused in some TMPFS file, keeping a memory secret pinned. Dragon, it allows you to scan all the kernel memory. You can program it. It's really powerful. So if you use Dragon, GDB stub, BPF tracing, you can do really, really powerful debugging and inspection. So it helps understanding the code.
Okay, there's a specific question. Next one is for Andrea. It's about asynchronous guest memory snapshots. It depends on user fault FD support and any chance of this getting merged. And how could we improve collaboration or cooperation with Linux kernel to merge such faster, such complex features?
I think it's about user fault FD write protection. It's a feature which was planned from day zero in user fault FD. In fact, you will see the placeholder already in the Linux kernel for it. And it's the causing of the post-copy live migration. In this case, you can do post-copy live snapshotting. And I think it's also going to be great for anything which is doing snapshotting, even on the bare metal. So if you have any process which is using fork and is actually copying the memory of the process to disk to take a snapshot of it while the parent is still running and doing copy and writes, this technology user fault FD write protection is going to improve that kind of workload of an order of magnitude. And Peter Xu, who's here somewhere, I don't see him, but it should be here, is maintaining the patch set. He did an awesome job maintaining it. He also improved the page faults, so I'm going to review it again. I reviewed the previous version, we fixed up something again, and it's really working well now, so I think it's good enough. I'm just being very careful in pushing it upstream because we want to push it upstream. It would help tremendously if Google could do some fathing on the I mean, we were talking about fathing, so it would be nice to do the fathing before the stuff goes upstream. I mean, it would be nice to fix all the bugs before syscaller finds something 0 day and we have to fix it when it's already merged. So, but from a point of view of design, I think this feature is solid and it's going definitely to be useful. So it's just, I think, a matter of months and it might be time to merge it upstream. And we'll see how the review goes, but I'm optimistic.
Okay, since we also have a nested KVM subject matter expert on the panel, any thoughts on the security state of nested virtualization? Nested KVM particularly, yes.
Well, it's another large attack surface, right? And it goes through multiple layers. The complexity is way, way higher, so the risk is, there's no question it's greater. Just last week, actually, I was looking at enabling a set of features for nested for one of our customers, and I, by default, we were enabling them by some flag that we control internally, and I, by default, enabled about half a dozen of them. And Jim Mattson, who many of you know from the mailing list and who I sit next to and work with every day, said to me, why are you enabling all of those? The customer only asked for 3 out of 6. And I think that is one of the pessimistic approaches that I really like, and I sort of caught myself because it is one of my themes. So I think reducing the attack surface as best as we can in nested is one way of dealing with it. And then going back to the fuzzing question, I'd love to see fuzzing working in the nested guest and trying to break through.
I want to add something. Fuzzing is fantastic because it does find things that you would never think of, but also running test cases. So one of the endeavors that we have attempted is to go to the Intel SDM and then also the AMD one and see what it says and compare it with the code and actually write the test cases, to expand the test cases to make sure it actually is correctly working. Now, you may find yourself surprised, but sometimes the Intel SDM is actually incorrect, but you know, that happens occasionally. But also adding actually and fixing the bugs in the nested to make it more secure, which is also something that's been focused. So I think the future is bright. It's going to take a while to get it working to the point that we don't have to stress about it, but eventually we'll get there.
Yeah, I was going to mention that I feel really good and confident that there's a lot of high-quality people looking at nested KVM and a lot of eyes on the security of it. And now that I'm more plugged into the security mitigation work that's going on and ongoing upstream, I know that nested KVM is taken into account in all of that.
So I'll just add to that. Thanks for mentioning the SDM, Konrad. One of the other features I'm looking at right now is the monitor trap flag, which is an Intel VMX feature that allows you to single-step a guest. If you look at the code today in KVM, it's one line, and it is when there is an MTF exit, forward it to L1. That means L2, the nested guest, has executed an instruction, the host gets that exit, and then it forwards it to the guest hypervisor, and we're done. So we would like to enable this feature in production, and I went and had a look at the SDM, and I have a spreadsheet that I think has 53 lines in it. Each one is a corner case for what happens in MTF. So yes, Paolo, we will have another big patch set coming at some point. But that's how complicated it is. I went from, and I'm hoping to boil it down to, I think, four similar cases, and I think it won't be too many lines of code, but the amount of work that it took, I probably spent a month just building up that spreadsheet, going through every corner of the SDM and saying, what are the possible cases here? How could this happen?
So a related question I see is that how important are nested VMs, and what depth have you tried or tested the most?
I think we've gone to 3 or 4. I think Oracle runs 4, if I'm not mistaken. Yeah, Ravello, yeah, right.
There's also a tool by Richard Jones, who should be in the audience somewhere, of libguest FS project. It's called Super Nested, that tries to run nested KVM guests until your host crashes or something like that.
But as for the importance, if you have operating systems using virtualization to give themselves a trusted base, as we discussed earlier, and if you have operating system vendors who are saying you only have tier 1 security support if you are using this, then nested becomes quite important.
So regarding that, actually, I think one thing worth mentioning is what Microsoft has done for nested, because Windows by default now uses VBS, and they didn't want to nest so much. They exposed the interface because it's a type 1 hypervisor that you can request the hypervisor to split it to security domain, but it's still a single type 1 hypervisor. It's not nested. So we could have, for example, created such a PV interface in KVM to avoid all the nesting over there. For example, today KVM does emulate the part of the TLFS API that Hyper-V exposed. So if we, for example, implement Hyper-V VSM in this emulation, then Windows running on top of KVM doesn't need to use nested to give VBS.
Okay, we're almost out of time, and actually are out of time. So one last parting thought or a wish list item, any of the panelists or all of the panelists, if you have parting thought or wish list for KVM-based stack.
So you folks are great. You're developing, you're using. The more you do it, the more there's things, new features and ideas, and this is really fantastic. So keep on doing what you guys are doing. And if you have a friend who doesn't know yet about virtualization, please teach them and tell them it's the best thing after sliced bread, and they should be using it. And better yet, they should listen to how, rewind 15 minutes ago, and how they can actually contribute and work on it.
I want to get to 0 VM exits a minute. Really. Finish virtualizing the hardware. We're so close with pass-through and posted interrupts and various other things. We should be able to get there.
So I've been thinking, I want more kernel engineers to use virtual machines. And I have a few examples because my department does the Linux kernel, my team does the virtualization. But sometimes they forget about virtual machines, and they waste time on physical hardware looking for a machine that does something like CPU hot plug. So just run things in virtual machines, use it, and especially for kernel engineers.
I would like to thank all the KVM contributors here, everybody who contributes. The more CPUs, the more human CPUs we put on this problem, the better it's going to get. And my ask would be that every patch you submit, think very hard about security and diagnosability and maintainability. As someone who's read a lot of KVM code, I would like to have more of that.
So my view is it would be great that the VR technologies would be leveraged to get higher security, because in my view the surface of attack of VRTO is much smaller than the surface of attack of the syscall of the kernel and sysfs and /proc. So Security is not black and white thing. Perfect security is probably an oxymoron. But we should try to get best practice across the whole stack and leverage all the technologies that exist, including KVM. And if you do StackComp, KVM, SA Linux, you get a really, really optimal combination. And there is no reason not to do the best you can.
Okay, thanks everyone. And we're out of time. There's plenty of interesting questions there. I'm sure there's more responses. So thanks everyone for joining, and have a good evening.